spent most of my life trying to understand the forces that shaped our planet. And as a geologist, it always seemed to me that rocks were right at the heart of things.
But now, I'm discovering it's not only volcanoes and colliding continents that have driven the Earth's greatest changes. Because at crucial moments in its history, another force has helped create the planet we live on. Plants.
Just look at this seed. It's small, it's brown, it weighs hardly anything. Looks pretty ordinary, but actually nothing could be further from the truth, because what it will become is truly extraordinary.
These are giant sequoias. Some are over 3,000 years old. And sequoias are the largest single life form on Earth. All from a tiny seed.
Yet even that pales into insignificance when compared to what the whole of the plant kingdom's done throughout the history of our planet.
It's a whole new story about our Earth. Told through remarkable images, captured for the very first time. And the latest scientific discoveries.
I love this. This is just fantastic. This programme is about just one type of plant, the most underrated, but perhaps the most important of all. One that, by taking on and conquering the rest of the plant kingdom, shaped the face of the planet and went on to help create human civilization. This is a story of the rise of that underdog.
For hundreds of millions of years, throughout the time of the dinosaurs, forests ruled the land. It was so warm, trees extended over most of the Earth. Imagine the Arctic and Antarctic without ice, carpeted with forests. Welcome to the planet of the trees. Today, isolated remnants of those expansive forests still exist. And here in East Africa is one of the most impressive. The Kasagoo cloud forest rises out of the dry plains of Kenya. Cloaked in moisture, it's much the same as it was then.
Oh, at last, look at that.
But millions of years ago, a challenger to the all-dominant trees came onto the scene. And the best way to find it is to climb right down into the depths of the forest.
It's never really elegant, this. This is when the adrenaline thrill starts to come in. To be honest, I'm not quite sure after you get to there's a little lip. It just seems to go straight down. This is the oldest forest in Africa up here. A relic, really, of the time when trees dominated the planet. So this really has a feeling of descending into that ancient lost world.
Back then, trees ruled, because wood gave them the strength to grow ever taller and to gorge on the sunlight all plants need. As you descend, you get a real sense of how trees bully and overshadow everything below.
We've come about 10 metres just into the canopy, and I've nicked the cameraman's light meter just to see what the light levels are doing. And already we've dropped by about a third. Now let's see how that light's doing. That's gone down by half. These huge trees here have stolen half the light.
Down here, the trees are intimidating. But it's not complete gloom. Patches of sunlight do break through to the forest floor. And those shafts of precious light offered a chance for a new type of plant, one that would come to take on the trees. So how did scientists discover the identity of the challenger?
It's all thanks to a rather enchanting piece of research involving what's inside this little box. You'll never guess what it is. This is a piece of fossilised dinosaur poo. It stinks. Phew. It's from a titanosaur sauropod, which is kind of like a brontosaurus, my favourite dinosaur as a kid. It weighed about 100 tonnes, which makes me think that this is just a fragment of something the size of, I don't know really, something big anyway. Scientists love fossil poo, coprolites we call it, because they tell us about the diet of animals, and particularly in this case about the plants that were around when dinosaurs were here. And when scientists analysed this one a few years ago, they found it contained something really strange.
Under the microscope, the scientists saw a fragment of a plant. It had a distinctive pattern, these figure-of-8 nodules. They turned out to be the defining feature of a family of plants they were astonished to see, the grasses. It was from 66 million years ago, evidence for the earliest grass ever found, called Matliitis. From its humble birth, grass would eventually become one of the most dominant forces on our planet. But its rise would be a David and Goliath battle with the trees. You can still find descendants of those early challengers today.
Plants like this. And we think these are similar to what the first grasses must have looked like. You can just imagine them struggling away on the forest floor, just feeding off little scraps of light, making it through the canopy. It's wonderful to think that dinosaurs the size of houses were trampling through forests like this, just grazing on little patches of grass.
But the dinosaurs' days of grazing were about to end abruptly. "65 million years ago, an asteroid 10 kilometres across killed them off. The grasses survived. But in turn, they would face their own crisis.
What was coming had nothing to do with the plants and animals that lived on Earth. It was all to do with the atmosphere, and that was changing for the most surprising of reasons.
Our air contains carbon dioxide. It's the gas that plants need to breathe to stay alive. But between 50 and 30 million years ago, this gas began to disappear, threatening all plants. The crisis started with the creation of huge mountain ranges like the Himalayas. The biggest period of mountain building in Earth's history. The freshly exposed rock was washed away. Some of the minerals ended up in the sea. And here they sucked the carbon dioxide gas out of the air, combining with it to form an entirely new type of rock. Limestone.
I can show you that limestone's got carbon dioxide in it because if I put a little bit of acid on it, it should fizz like mad. What this is doing is it's liberating carbon dioxide that had been in the ancient atmosphere and has now, for the last few million years, been locked away in this rock. By 30 million years ago, as the mountains had risen, the level of carbon dioxide fell. In fact, carbon dioxide levels dropped to a sixth of what they were beforehand, which is an enormous fall. And for the plant kingdom, it meant crisis.
Without enough vital carbon dioxide, many plants, including the grasses, were struggling to survive. One way to reveal the impact this had on plants is to look at a clever bit of human machinery. The car engine. Because what's under the bonnet shares surprising similarities with plants.
The car engine relies on two things to work. It needs petrol and it needs oxygen from the air. Inside the engine, these two are combined to release the energy to power the car. It's called combustion.
Like the engine, plants also need a gas from the air to work. In their case, the carbon dioxide. So for plants, the collapse of carbon dioxide levels was similar to a car engine starved of oxygen.
If I block the air intake, you can feel the engine stuttering away because it's struggling to get the oxygen that it needs to work.
With less carbon dioxide in the atmosphere, plants also began to stutter. But the grasses were evolving a new and ingenious invention. Again, the engine provides a parallel.
But there's a piece of shiny machinery here that any petrol head will recognise. What that does is the opposite of my hand. It forces more oxygen into the engine. It's called a turbocharger. More oxygen means that the petrol burns more fiercely, and that means more power. Power enough to do this.
Evolution often comes up with our cleverest solutions during desperate times. And one group of plants, the grasses, turned this crisis into an opportunity.
Grasses like this is elephant grass, which is one of the fastest growing plants in the world. In 3 months, right, this stuff grows 4 metres. That's that much every day. This phenomenal growth rate was only possible because of a technology that evolved 30 million years ago. A design so effective that if you were a mechanic, you'd be blown away.
The new grasses came up with the equivalent of a turbocharger inside their leaves. It's in the cells of the leaves that photosynthesis occurs, where carbon dioxide is combined with water to make sugar. But the new grasses created an add-on. Rings of specialist cells known as bundles. It all acts as a miniature pump, sucking in and concentrating vital carbon dioxide. So although there was less carbon dioxide in the air, the grasses had the edge over other plants.
You know, when you study the planet, you're so used to seeing the big events, like, I don't know, ice sheets melting and volcanoes erupting. But with the rise of turbocharged grasses, you've got something that's the tiniest of events. It's something almost invisible, tucked away inside the leaf of a plant. It's what makes the story of plants just so fascinating.
The grasses had found a way to survive the crisis. But forests still ruled the world. The huge trees had also survived. Then the underdog unleashed a devastating new weapon. "8 million years ago. By now the climate had altered. Much of the earth was drier than ever before. It was the moment grasses had been waiting for. The grasses had evolved unique properties that made them especially flammable. When dry, they became like a tinderbox. All they needed was the spark. Today there's an ideal place to see what happened 8 million years ago. Here in the national parks of South Africa, rangers deliberately start huge fires to manage the land. And for me, it's the perfect opportunity to see how back then, grasses exploited fire.
So we're going to get a chopper coming right down this line, dropping incendiaries all the way along here.
Chief Fire Starter is Chris Austin.
Thanks for the three. Thanks.
He coordinates the helicopter crew as they drop fire pellets onto the grass. Artificial lightning strikes.
So what's going to happen is they just sit there, they just open up, ignite, and then you just see them erupt.
It takes 46 seconds, which is quite a long time.
46 seconds, that's nice and precise. There we go. There's one. Yeah, there's probably another one there. But 13.
See her at night now.
Behind us.
There she goes.
There. And then over here, we got ourselves another one. So this line, this whole line now, is just going to go up into a wall of flame. There's another one there. Is this safe now here? But she's going to go up slope, yeah? She's going to go away from us.
And of course, if the wind's pushing it, it'll accelerate. You can see that's now being pulled by the slope.
Oh, I can feel it. Front of my face already. Look at that, that's amazing. It's just a wall of smoke and flame. Unbelievable.
The most aggressive fire that I've seen moved at more than 3 meters a second, which is
3 meters a second, that's phenomenal.
it's really quick. You can't outrun it. The fires that kill people are grassland fires because they're so fast moving.
And that's not all. Grass burns in a special way. A way that was devastating to its enemies.
Kind of fallen into it.
To discover more about its properties, I volunteered to enter into the heart of the fire.
This stuff that's going in now is not kind of medical monitoring. This is actually for monitoring the temperature of the fire. It's a thermocouple of wire that's going to go running down, in this case down my leg. I think it's probably the first time this has been done, really.
First time I've ever done this.
First time you put your first time you put your hand down a man's trousers. If you get stuck, that's us virtually married.
Once in the flames, we hope to combine readings from the heat sensors on my suit with a thermal imaging camera to reveal the secrets of a grass fire.
Okay, it's picking up speed. I can't believe I'm seeing this. It's starting to come towards us. This just seems like one of the daftest things I've done. Look at the flames!
Grass fires are very different from other fires. The readings show that the hottest area of the fire, the white parts on this image, is not in the burning grass, but a metre above it. The temperature here is over 360 degrees. Grass ignites more easily than other plants and is transformed into a volatile gas. This gas rises and burns even hotter than the grass itself, making it one of the fiercest and fastest fires in nature.
Oh, I know this sounds really strange, but it was actually quite a privilege to be in there. You know, normally if you're stuck in one of them, you just don't come out. It was great at one point, the flames come up, and I just looked down, and it was just lapping against the mast. You kind of feel sorry for the trees.
The next day, the fire still smoulders. It's so strange. Why did grasses evolve to encourage fires to take hold? ripping through the landscape and destroying plant life. It seems suicidal.
Grasses don't just encourage fires to start, they're also designed to survive them. In fact, they're the most fire-resistant plant on Earth. And you can see here, this all looks scorched. God, look at it still. Look at the charcoal and smoke there. But the thing is, if you just peel this back, you quickly find that, look at that, there's a lot of that still alive. In fact, the trick really, the solution to why grasses can survive isn't on the surface, it's just below the surface. Because if you open up these stalks, you can see that right here is a little bud. It's stuck under a kind of insulated, thick coating. It's kind of tucked away in its underground bunker. It's still alive. So you look around here and you just think everything's dead, and that tree certainly is, but the grass is just biding its time. It's very much alive. You know, this scene, could easily be a scene from 8 million years ago, where the grasses just really quickly recover and recolonise. And the sneaky bit is they do it much faster than trees.
In the wake of this onslaught, the forests started breaking up. The grasses were on a land grab, conquering the territory once held by the trees.
The expanding grasses turned Earth into a flammable planet, a fireball world. It must have seen about 1 million trees burned, and black ash filled the sky for hundreds of thousands of years. And for the trees, this was apocalypse.
The world was ablaze. The Challenger had sparked a revolution that was changing the face of the planet. But the global rise of grasses wasn't just reshaping plant life, it was transforming the animal kingdom too. So how do we know this?
The effects of the spreading grasses have been revealed by one of the most elegant pieces of forensic science. Part of the evidence has been discovered here in North America, and it comes literally straight from the horse's mouth. Come on, Jim. Oh!
When an animal eats a plant, the carbon of the plant is absorbed into its teeth. Studying the teeth tells you whether the herbivore is eating the leaves of trees or the new grasses. And the fossil teeth from millions of years ago tell a remarkable story.
This is a result of the scientific analysis of tooth enamel from herbivores in North America. You can see down here, this is us going back in time in millions of years. Now the thing is, up to about 8 million years, to about here, you can see that herbivores are largely eating shrubs and trees. But then there's a really dramatic change about between 7 and 6 million years ago. And after that, they're eating grasses. And the thing is, this sudden switchover isn't confined to North America. Here's a graph for South America, and here's a graph for Africa, and also for Asia. You put them together, look at that. What these graphs tell is the same story, and that is, in a period of about 1 million years, a geological instant, the world's herbivores dramatically changed their diet so that they're eating the new grasses.
This discovery proves that by 6 million years ago, grasses were dominating the land. It was a domination that would have striking consequences for many animals. And it involved another piece of clever engineering from the grasses.
Ah, this is it. This is the stuff I've been looking for. This is the sharp stuff, I'm pretty sure of it. Let's have a little look. Ah, yeah. Oh, that's something we've all done in the past. Cut ourselves in a blade of grass. Look at that. I'm bleeding. But have you ever wondered why that happens? It's actually all to do with something that coats the edge of the leaf.
Grass extracts a mineral called silica from the soil. The silica is built into row upon row of tiny daggers along the leaf. It's a defense to discourage animals from eating it. Although tiny, these weapons led to one of the biggest extinctions of mammals in Earth's history. The world had been full of many different plant eaters, including the vast Baluchitherium. These 20-ton beasts were the largest mammals ever to exist. They fed off trees and shrubs, but as their food source disappeared, these animals died out. In North America alone, grasses led to the extinction of over half of all plant-eating mammals. But some herbivores thrived.
It's all down to the teeth again. Who would have thought that gnashers could be so important? You can see how the survivors cope with this skull here. They developed harder teeth to bite through that silica-edged grass. And also longer grinding teeth so that it didn't matter if they get worn down. The creatures adapted. And this is one of the results. The jaw of a modern day horse. Like Tank here.
By 6 million years ago, the triumph of grasses had caused the death of many types of animals, while creating vast herds of new ones. The more familiar plant eaters we know today. But that's just the start. Because if you've got herbivores consuming silica-rich grasses, all that mineral has to go somewhere. As manure. The herds of herbivores were producing millions of tons of manure every day. It's washed away into rivers until finally it reached the ocean. And within it was all that silica.
It's out in the oceans that things really began to take off. Because it's out here that there's creatures that are addicted to this silica.
These creatures are microscopic. A few hundredths of a millimetre across. They're diatoms, a type of green algae. Diatoms are wonderfully delicate, like some kind of alien architecture. But essential for the construction of their tiny skeletons is silica. 5 million years ago, they were feasting on huge amounts of silica from the grasses.
For the diatoms, it was like Christmas. Their numbers exploded.
And diatoms are crucial because they form the foundation of the ocean's food chain. With more diatoms came huge shoals of anchovies and herring that eat them. This in turn attracts predators like seabirds and dolphins, and even bigger hunters. But it's from space you really appreciate their importance. They appear as vast green blooms. When they bloom, they cover over 1/10 of the oceans. They're green because, like plants, diatoms contain chlorophyll. And like plants, they all release oxygen.
Those photosynthesizing diatoms produce about 1/4 of the oxygen in the atmosphere. So if you like, every fourth breath you take, on average, has been exhaled by the diatoms. They really are the lungs of the ocean.
It's remarkable what the humble grasses had achieved by 5 million years ago. A once forested planet was now dominated by open plains. 8,000 different species of grasses covering 1/4 of all land. They'd selected which animals would live or die. And they'd fundamentally altered the oceans, playing a crucial role in the makeup of our atmosphere. Yet, perhaps the most important impact of this remarkable plant was still to come. The impact on our story. Human beings. And that's why I've come to the savannah of West Africa.
I'm in Senegal to see a scientific first. It's a discovery that's got profound implications for our understanding of our own past, because it's here in Africa that our earliest ape ancestors emerged.
5 million years ago, why did one group of apes leave the trees for the savannah and develop so differently, eventually becoming human? Well, the chimpanzees here might provide some answers. Because unlike almost all other chimps in Africa, the ones here in Fongoli live on grasslands.
Jill!
Hi!
Hi!
Welcome.
I'm Ian.
It's what makes them so fascinating to anthropologist Jill Preetz.
This is HQ, Chimp
Yeah,
HQ,
this
is
is
it?
home base. So every day we take off wherever they're at.
Jill has spent 10 years studying the Fongoli chimps. She's most interested in parallels between the unusual behaviours of these chimps and what might have happened during the evolution of human beings.
Settled round the waterhole like that. I wasn't expecting that. I guess I was expecting them kind of swinging through the trees, but look at them, they're just ambling along and awful. Perfectly happy down here on the ground, walking through the grass. They look so human, I know it's obvious. Really obvious thing to say, but they just look so human.
The Fongoli chimps have other human attributes. They are proficient at using tools, like sticks for collecting termites. Many chimps in Africa catch termites this way, although these chimps do it more than any others. But what makes them really special is a hunting technique, one that is unique.
Well, I think that probably the most exciting discovery we made was that they hunt with tools, which before we had thought only humans did.
How is that?
They'll fashion branches into sort of like a spear, and they'll use it to jab into these tree hollows where you have another kind of primate, a bush baby, and then they jab it into the hole.
Jill's filmed this remarkable behaviour, the first time it's ever been recorded. It shows a chimp using a spear he's made to stab and kill a mammal, a bush baby.
Yeah, that was something that, again, we sort of had used that to define humans.
Really? So
Yeah.
that's starting to blur the boundaries.
Yeah.
The chimps of Fongoli are the only ones in the world that have been observed using spears to hunt mammals. Jill believes they've had to come up with this behaviour to cope with the harsh and dry grasslands. It's a more hostile habitat than the forest, so the chimps here have to be smarter. And Jill has discovered a final extraordinary behaviour of these chimps. It also reveals more about how our ancient ancestors might have evolved as they moved out of the forests.
This is a nice one, I think, from the wet season. So this is a grassland.
I can see a group of them in there. Oh yeah, what, 3 or 4 of them.
You can see them just above the grass, but watch what they'll need to do here.
One of them just stood up.
Yeah. I mean, he obviously has to do that to see over the grass.
I want to see that again, yeah, let me see that.
Many scientists think this is perhaps a mirror of what happened as our own forebears stood up on the grasslands for the first time. It allowed them to keep an eye out for predators and prey. And eventually, to evolve walking.
That's incredible. We're seeing chimps in the wild, standing proud in the savannah grasslands, and looking incredibly comfortable as well.
It's exciting to see it.
It's the grasslands that's kind of driving, encouraging them to develop that way.
Yeah.
What, to be more resourceful, more resilient?
I think so. They have to be creative and resilient.
I just get this weird feeling that I'm looking at a bit of video from 4 or 5 million years ago. Do you know what I mean? That could be the scene.
Mm-hmm.
Here at Fongoli, you can actually see what scientists think happened when grasses shaped our ancient ancestors and encourage them to make those first upright steps onto the savannah. And it really brings home how our human journey began on the grasslands.
Over the next 5 million years, these ape men continued to evolve in Africa. Until eventually they became Homo sapiens. And then, 100,000 years ago, these new people, for they really were people now, like you and me, began to migrate across the rest of the world. At this point in time, our ancestors were hunter-gatherers. They were living a tough life in small family groups, killing wild animals and collecting berries and roots to eat. But grasses hadn't finished with us, because they'd trigger the greatest revolution in humankind's existence. It's not in Africa, but here in southern Turkey that archaeologists believe they've discovered why that revolution happened. The place is called Göbekli Tepe.
For me, this is one of the most exciting sites in modern archaeology. Because here at Göbekli Tepe are some of the oldest buildings in the world. They date to nearly 3 times the age of the first Egyptian pyramids. And there's a real mystery here. Who built this place?
And more importantly, how could they have done it? This astonishing structure is 12,000 years old. It lay buried and undiscovered until 1994.
Hello.
Hello, Jan.
The archaeologist who unearthed it is Klaus Schmidt.
But it's great to be here.
Hi, welcome in Enclosure C.
Enclosure C. What a place. It's spectacular, isn't it? I mean, these are great.
Big question is, who are they? One thing is very important. Never a face is depicted. They are always faceless.
I saw you, as you came down, you were working on a very sophisticated one here.
Yeah,
This looks amazing. What
This
is
is
it?
a masterpiece of craftsmanship. It's one stone. It's made from one stone. We have a flat relief of a boar, and we have this high relief of a leopard.
This is an extremely complex society.
Yes, and this is a surprise. We didn't know this. We didn't expect this. Or what we are doing here, we add a chapter in world history, a chapter which we didn't know it exists before.
To construct Göbekli Tepe with its 50-ton megaliths would have needed a huge army of well-organised workers. Yet 12,000 years ago was the Stone Age, a time when people were supposed to be hunter-gatherers living in small groups. How did they sustain the numbers essential to build such a vast temple? The answer lies a short distance away. Within sight of Göbekli Tepe are the Karacadag Mountains. Here something happened at this time that would change our world forever. It was all to do with one particular type of grass.
It's an ancient type of wheat which grew totally wild, just as it does today. It's called einkorn wheat.
12,000 years ago was a time before farming. The people here would have been desperate for whatever nutrition they could gather.
Yet collecting it presented a huge problem. Let me show you why. When the head of the wheat's ripe, then just the tiniest of touches and look what happens. It just scatters everywhere. And that's because the seed is attached to the plant so precariously. Imagine if you were trying to collect enough seed for a meal. I mean, I can hardly even see where they are. There's one. Oh, don't worry. It would drive you mad.
frankly, it's hard to believe anyone would bother. But everything was about to change, triggered by a crucial event.
A tiny alteration in the genetic makeup of a wild wheat plant. Just one gene in just one single plant.
That mutation has been traced back to here, just 30 kilometres from Göbekli Tepe. If you look closely, you can see the difference between the two types of wheat. In the original wild wheat, a special ridge of cells between the stalk and the seed breaks down as the plant ripens. And this allows the seed to fall away. But in the wheat with the genetic mutation, these cells remain as a solid band. It means the new wheat never lets go of its seeds.
Now, under normal circumstances in the wild, that would doom the plant because it just couldn't scatter the seeds. Look, you bang it and nothing happens. But it turns out that for one animal species, this trait was really beneficial. Us. Because the seed remained on the stalk after it had ripened, it meant that not only could the people who lived here collect more grain, they could also begin to farm it. In other words, they could take some of the spare seeds at the end of a season, put it back in the ground, and then harvest the new plants the following year. It was the dawn of domesticated wheat.
And this wheat gave us bread.
A fabulously concentrated form of energy. It could be carried, it could be divided up, it could be stored. And in turn, bread would lead to something even bigger.
In order to build Göbekli Tepe, the Stone Age people turned their back on hunter-gathering. They became the first farmers. 12,000 years ago, they began to sustain themselves with bread, made from the grass we call wheat. Now they could feed the huge workforce required to construct such a vast and sophisticated temple. The mystery of Göbekli Tepe was solved.
People had been hunter-gatherers, and now this site marks the end of their time, the end of the period, and the beginning of a new age.
So Göbekli Tepe is part of that chain reaction. It's
Göbekli,
a cultural...
The people
Yeah.
being in Göbekli Tepe are the first people having bread also in their villages, not only here, but also in their villages.
That's incredible, isn't it? To think that these were the first people to kind of
Yeah.
taste bread. And
Yeah,
it was
sure.
And the idea then that it was bread
Yeah.
that was the kind of energy source, essentially, the sustenance.
Exactly. It's a turning point in world history.
There's one last thing that I find intriguing. Our ancestors must have felt that they were the masters of this new crop, in the same way that we still feel today about farming. We are in control of the plants that we grow and harvest. But think of it for a minute from the wheat's point of view. I mean, here's a plant that's done something really clever. It's attracted an animal that's prepared to sow it, to nurture it, to protect it from competitors and scavengers. It's also prepared to disperse its seed by hand, without the plant having to do a single thing. So it begs the question, who's using who? Human beings had now invented a way of harnessing the power of plants. And once invented, it could never be reversed. Because farming allowed us to come together in bigger and bigger groups, to build villages, towns, and eventually cities. A world once dominated by forests and dinosaurs had given way to a world of our own making. I've always been fascinated by how our planet changes over time, over the 4.5 billion years of Earth history. And what's astounding is how important plants have been in changing that original lifeless rock into this vital and vibrant world that we live in today. Our home.
Over the series, we've seen how plants gave us the oxygen in the atmosphere. We've watched as the rise of flowers painted a drab world with brilliant colour. And we've discovered how plants shape the animal kingdom.
And for us, the humble grasses played the most important role of all. They drove the rise of our ape-like ancestors and ultimately triggered the birth of civilization.
Plants made us and the world we live in.
Heading out into the garden for Winter Watch here on BBC HD at 9 tomorrow night. But back to tonight now, and we've drama up next with Survivors.